Intermolecular forces, as the name indicates here, intermolecular. It means we are talking about a force that is present between the molecules. Say, for example, we have a glass of water. In the glass of water, we have many molecules of water. Now, of course, these H2O molecules are connected with each other with some mean. So these H2O molecules are connected with each other with the help of a force, and this force is called as intermolecular force. As you can see here, we have one water molecule here and another water molecule here. Now, this hydrogen is partial positive and this oxygen is partial negative due to the electronegativity difference. And due to this difference, there is attraction between them. And due to this attraction, there is a force between them, and that force is called as intermolecular force. That means a force between the molecules, and this is how all the molecules are connected with each other. What are intermolecular forces? Intermolecular forces can be attractive also, and intermolecular forces can be repulsive also, and they are between a molecule of a substance. These forces are the attraction between the individual molecules of a substance. So when there are attraction between the individual molecules of 2, 3, 4, 10, even 100 of molecules are there in a substance, the attractions between them are the intermolecular forces. Intermolecular forces, often abbreviated to IMF, intermolecular forces are very important because these are the ones that are responsible for the physical properties of any matter. Say, for example, boiling point, we have melting point, density. As we just discussed, that intermolecular forces are responsible for the physical property, and boiling point is one of them. So, intermolecular forces and boiling point have a relation. The boiling point of a substance is directly proportional to the strength of intermolecular forces. The more stronger the intermolecular forces is, the more the boiling point is. On the other hand, by comparing the boiling points of different substances, we can compare the strength of their intermolecular forces. Say, for example, here we have a molecule A and here we have a molecule B. The boiling point of molecule A is 100 degrees Celsius and the boiling point of this molecule B is 32 degrees Celsius. Now, what does that mean? With the help of these boiling points for a substance, we came to know that if a substance has 100 degrees Celsius boiling point, so it means the intermolecular forces that are present in between are stronger. And on the other hand, if we talk about the substance B, boiling point of substance B is 30 degrees Celsius, so it's very clear that the intermolecular force of this substance B is weaker as compared to the substance A. So this is how, with the help of the boiling points, we can predict either the intermolecular forces are stronger or weaker. The heat absorbed by the substance at its boiling point is actually used to break the intermolecular forces and to convert a liquid into a vapor. So this is how intermolecular forces are linked with the boiling point. Then we have some types of intermolecular forces there. The first type of intermolecular forces is dipole-dipole interaction. As the name indicates here, dipole. Di means two and poles means partial positive or partial negative. So it means in these kind of interactions, partial positive and partial negative, these poles are involved. So these forces occur when the partial positively charged part of the molecule interact with the partial negative part of the molecule and a force generate between them, and this force is called as intermolecular force, and specifically it's called as dipole-dipole interaction. For example, here you can see the molecules of HCl here. Now, this chlorine is partial negative due to electronegative difference. In this side, this hydrogen is partial positive. Now, this is partial negative, this is partial positive. Both of them will attract each other, and due to this attraction, there is a generation of force between them, and this force is actually called as dipole-dipole interaction. And dipole-dipole interaction is a type of intermolecular force here. Hydrogen bonding. Hydrogen bonding is a special kind of dipole-dipole interaction. It's also an intermolecular force, and hydrogen bonding is considered as the strongest intermolecular force. Now, in the case of hydrogen bonding, this hydrogen with a partial positive charge interact with the partial negative charge molecules. Whenever we have oxygen, nitrogen, and fluorine in any molecule, at that time hydrogen bonding will be there, and the partial positive of hydrogen will interact with the partial negative of this oxygen, nitrogen, or fluorine, and a force will be there in between, and that special force is called as hydrogen bonding. For example, here we have the molecules of water. Here we have three molecules of water. This hydrogen has a partial positive charge. This oxygen has a partial negative charge. Now partial positive and partial negative, they will interact with each other. And after this interaction, there is a force between them, and this force is an intermolecular force, and specifically it's a hydrogen bond, because this time the bond is between this hydrogen and oxygen. So that is why this intermolecular force is called as hydrogen bonding. Third type of intermolecular force is London dispersion forces. London dispersion forces are the weakest of the intermolecular forces that can exist between any molecules. They are weakest because usually they are between non-polar molecules. For example, we have these molecules. This is the molecule of chlorine, and this is also chlorine. Now, as such, there are no poles. We can't see any partial positive and partial negative charge here because chlorine and chlorine both are same. It's a non-polar covalent molecule. So they don't have any partial positive and partial negative charge. Now, in this case, there is a temporary induced dipole. Due to that temporary induced dipole, which is due to the distortion of electrons, so that distortion of electrons between the atom is temporary. Due to that distortion, this chlorine and this chlorine will show partial positive, and this chlorine will show partial negative, and this is just for some time. That is why it's temporary induced dipole, and due to that temporary induced dipole, there is attraction between this chlorine and this chlorine, and there is a force between them, and this intermolecular force is called as London dispersion force, and this is temporary. That is why these intermolecular forces are considered as the weakest intermolecular forces. So yes, this is all about our today's lecture. If you want more such videos, please don't forget to subscribe. Thank you very much.